In this video, you will be able to understand how a combinational circuit consisting of series, parallel, star and delta network can be solved. Here in this video, you'll understand the stepwise derivation for star to delta and delta to star transformation, and how do we analyze what is the formula in converting star to delta and delta to star transformation. Myself, Professor Mohan B.S., Assistant Professor, Department of EEE, SJBIT. Star delta transformation, and how do we apply for different circuits. Star, the alternative names for star are Y, T, 4-wire system. So the four ends are A, B, C, and the midpoint, which is known as N, that is neutral. Delta, so delta, the alternative names are mesh, pi, or 3-wire system. Three ends are A, B, C, and N, which all in star would not appear in delta. So let us understand first delta to star followed by star to delta transformation. So the knowns are delta. We are going to derive the equation for RA, RB, RC with respect to delta elements RAB, RBC and RCA. So for delta network shown, what is the equivalent resistance across AB? So across AB one can neglect point C, thus RCA and RBC appears in series. Then these two branches are in parallel, right? So that is shown in equation 1. Similarly, in star network, what is the equivalent resistance across AB? So when you see here, when a person stands from point A and needs to travel to point B, he travels through RA and RB. Thus we can neglect RC. I hope you've understood why are we neglecting RC. Thus we can read the circuit as shown, and the R equivalent across AB is RA plus RB. For equivalence, we equate equation 1, which is equal to equation 2, as shown in equation A. For delta network, what is the equivalent resistance across BC? Neglecting point A, RAB and RCA appears in series, and these two branches are in parallel. Thus, we can rewrite them in equation 3, as shown here. Similarly, for star network, what is the equivalent resistance across BC? We can neglect RA. I hope you understood why are we neglecting RA. Thus, as shown in the figure, across BC the equivalent resistance is RB plus RC. For equivalence, equating equation 3 and 4 as shown in equation B. Similarly, for delta network, what is the equivalent resistance across CA? Neglecting point B, RAB plus RBC are in series, and these two branches are in parallel. Thus we write them as equation 5. For star network, what is the equivalent resistance across CA? So here one can neglect RB, right? Thus across CA the equivalent resistance is RC plus RA. The equivalence is as shown in equation C. Thus ABC are the equivalents of star and delta. By adding equation A, B and C, on the LHS we have RA plus RB plus RB plus RC plus RC plus RA. Similarly on the RHS, so let us see how do we add. On the LHS it can be reduced as shown here. Similarly in the RHS we can reduce as the denominator is common, we can add. But one can observe that RAB RC appears twice, RAB RBC appears twice, and RCA RBC appears twice, thus rewriting as shown here. This can be further reduced as shown in equation D, cancelling the constant 2 on both sides. From equation D one can find RA, RB or RC. So let's see. Let us find RA and then find out how do we find for RB and RC. So when we equate RA from equation D, we get the equation as shown. We have to substitute the equation for RB plus RC from equation B. Now this can be further reduced. As the denominator is common, we can subtract on the RHS. But one can observe that RAB, RBC, they are same but with opposite polarity, thus they cancel. Similarly, RBC, RCA, they are same and they can cancel because they are with opposite polarities. Thus RA is equal to RCA into RAB divided by RAB plus RBC plus RCA. Thus we have converted the equivalent delta to star. So let's see. So this is the star delta network RAB, RBC, RCA, where we require the star network RA, RB, RC. We have now derived for RA, and let us write the equation for RB and RC. So one can see RA is in contact with two delta elements. Which are those two? RA and RAB and RCA. Thus product of those two divided by the summation of all the delta elements. Can we now equate for RB? So RB is in contact with which two delta elements? RAB and RBC. So product of those two divided by the summation of all the three delta elements. Similarly, how do we write for RC? RC is in contact with which two delta elements? RBC and RCA. So product of these two divided by the summation of all the delta elements. Thus, for known delta, its equivalent star is derived. Now, let us derive star to delta transformation with the help of these three equations. For star to delta transformation, multiply equations EF and FG and GA. Let us take one by one. So when we multiply EF, on the LHS we have A into B, on the RHS we have multiplied and denominator square, and one can observe in the numerator in equation E and equation F we have RAB twice, thus RAB square. Similarly, now when we multiply FG, on the LHS we have RB into RC. Similarly, now on the RHS we will have RCA into RAB into RBC square. So one can analyze for G into E. This equation can be further reduced as shown below, and this can further be reduced as shown as equation H. Now using equation EFGH, we can now equate or find the equivalent delta parameters RAB, RBC and RCA. So one has to divide equation H by equation E or equation F or equation G. So we are showing for one, and then we'll analyze for other two parameters. This is for equation H on the LHS, and this is equation E on the LHS, and this is equation H on the RHS, this is equation E on the RHS. So one can observe that some terms cancel, right? So you can see on the LHS we can rewrite as shown here. In the RHS the cancel out and the leftover is RBC. So this is its equivalent delta. So now between these 3 points, the known were star. Now we have derived its equivalent delta, that is RBC. So one can see, or one can inspect for other two delta parameters. Let us see. RBC is in contact with which two known star? RB and RC. So product of those two plus their summation divided by the one which appears perpendicular to RBC, that is RA. Similarly, let us now equate or write the equation for RAB. Now, RAB is in contact with which two star elements? That is RA and RB. So product of those two plus their summation, and we have to divide for only the product RA into RB. So which is that division? That is the one which is perpendicular, that is RC. Similarly, how do we write for RCA? Which two are in contact with RCA? RA and RC. So product of those two which appears perpendicular, RB, divided by RB plus the summation of those two which are in contact with RCA, that is RA plus RC. Thank you for watching our YouTube channel and the video. Please do subscribe to enhance your knowledge with the upcoming videos.